This is a video on using the Pythagorean theorem to build a deck along the side of a house. This is the top view of that deck, and so it's 20 feet along the side of the house, and it comes out from the house 10 feet along these two boards, and this is another 20-foot board on the other side of the deck. And what I want to show you is that if these two diagonals are equal in length, so this diagonal here and this diagonal here, and in this case, using the Pythagorean theorem, those diagonals are 22 feet and 361 thousandths of a foot. If they are equal in length, then this whole deck will be square to the house. So when a builder says, I want to make sure the deck is square, what they mean is that these boards come out from the house at a right angle. So there's a little square here showing you that it's a right angle. So when a builder says, I want to make it square, that means they're making sure that these are right angles. And if these two diagonals are equal, that deck will be square. They will form right angles. So this is a link to a video in which the presenter takes you outside and shows you making that deck square, making sure that those angles are right angles. So this is a QR code that will take you to that video, and this is a link that will also take you to that video. And I will put this link in the discussion below. So let's start with a right triangle that is 20 feet along one side, 10 feet along the other side. So using the Pythagorean theorem, this is 10 feet squared is 100 square feet. This is 20 feet squared, which is 400 square feet. Add those two squares together, you get a larger square, which is 500 square feet. And the side of that square is going to be the square root of 500. So this length will be the square root of 500. That's what the Pythagorean theorem helps you figure out. So the square root of 500 is 22 feet and 361 thousandths of a foot. So now, this is going to be the diagonal of the rectangle. So if I take this right triangle, I know it's a right triangle now because it fits the Pythagorean theorem. If I make a copy of that triangle, so I'm going to just copy that triangle, I'm going to rotate it around and put it right here. This is the same hypotenuse. It is the same length. This is 10 feet coming out from the house, and this is 20 feet on the other side away from the house. So now I have two right triangles that go together to form a rectangle. I know that it's a rectangle because now I have four right angles, and I have two sets of parallel sides. But just to ensure this, just to make sure that you can use the Pythagorean theorem to make that deck square, I want this diagonal as well. So I'm going to take this triangle and I'm going to flip it over right here. And I'm going to take this triangle and I'm going to flip it this way. Same two triangles. Everything is the same length. These are also right angles, but now I have a diagonal going in the other direction. So now I have those two diagonals that are both the same length. They are both 22 feet and 361 thousandths of a foot. So in the end of the video, the presenter switches from feet to inches. You just have to be aware. So he's looking for a diagonal that has a length of 268 inches and 1/3 of an inch. But what if it's not a rectangle? What if it's a parallelogram? So these are not right angles. So I'm going to just take the two sides. I'm going to shift it up a little bit so these are not right angles anymore. And what you'll see is that the diagonals are different lengths. So the red is the original length. They are the same. But now this diagonal that goes this way is longer than the red diagonal that we were using for the rectangle. So this diagonal is longer, and this diagonal is the blue length that's behind this red length is now shorter. So this is the original diagonal, and this diagonal is now shorter. So if I just have someone else hold a tape measure that's 268 inches and 1/3 of an inch this way, and I just tap this corner up here, tap it a little bit, move this more towards a rectangle, keep tapping this length. When this length is 268 1/3 inches, then I know that I will have a rectangle. I know that the framing of this deck will be square with the house. This board will form a right angle with this board. So tap it a little bit more, and so now these two lengths are equal. So this length is 268 1/3 inches, and this length is 268 1/3 inches. So now I have a deck that is square with the house. So watch the video, and at the end of the video, you're going to see this exact same idea, but the presenter is actually building the deck, and he's measuring to make sure that it's square.